welcome. I'm very happy to be here. I've been speaking at CodeMotion before, but never in Amsterdam. Well, also because it's the first CodeMotion you have here, so it's brilliant. And I'm going to present you, I'm going to talk to you about microservices, and there will be a bit of introduction, and then we will see some example with Node.js, which it's what we have been working on since a year or so. And yeah, there may be some anti-pattern. We have a lot of content, so I think we will take it, take it by hand and see what happens. And of course, with the presentation now with 100% more llamas, you won't understand this joke, but it's about old conference that I had, but yeah. Now, anyway, who am I? I am a developer, first. I'm a developer, I'm still writing code. You can check my GitHub if you don't believe it. I was originally an assembler developer, if anybody remember those days. And I've been working with Agile, XP very early. And I founded Agile user group. And now I'm the head of engineering in Workshare, which is a 200-size company between London and San Francisco. And I work in London. And yeah, I'm a microservices addicted since 2013. So, does everybody know about microservices? Who have been using microservices? Okay. Oh, well, yeah, quite a few. That's good. That's good. So, I will go faster in the microservices part. So, and this is the agenda we're going to follow. Very easy. Why, what, demo, some anti-patterns, a little of everything. So let's go. There's not a lot of time. Wait, why microservices? This is very important. Why we want to use them. So probably because of this. If you're living in what's called a monolith. So all your code base belong to the monolith. And you have this big thing that you manage and deploy, maybe in the cloud. I don't know. And yeah, we have some symptoms that you may recognize. So for example, your IDE is bloated. So you open your code base and your IDE hangs for 10 minutes, reloading things, like that, no? You are locked into a language. So you would like to use new cool languages because it's cool. You want to move on, do something new. Maybe you have been a Java developer for a long time. You want to try something new. You cannot, because your monolith is all written in Java, and you have to stick to Java, or Ruby, or, I don't know, C#, or whatever you have in your... You would like to use F#, but whatever. Your tests takes hours to run. We have on our company, we had, and we still have, we're moving out, a Ruby on Rails application, which was our original monolith. And when we run integration tests, they take 6 hours to run. 6. So you compile, click, and then wait for a test. Yeah, tomorrow maybe. So that's not how it should work, right? I mean, in my view, it should take seconds. You have those DB migration, which are huge and scary. Anybody doesn't know what a DB migration is? No? All cool. So the problem with the monolith is that you have a massive DB migration, which usually impacts several tables at the same time, and are very scary. And when you do a DB migration, it's a stop-the-world moment. You have to stop your services, usually, do the DB migration, and then you restart your services with a new code. And this is very bad. You don't want to do this if you can. You always scale everything. So you have this monolith, right? And this monolith contains reporting function, for example, that I use very seldomly. So you do a report once a month, once a week. And then you have the session API in the same monolith that are called 200 times per second. And then you have more users, no? And you want to put another instance of your monolith in production, right? Imagine you have an engine yard. Oh, engine yard, you click a button, you publish a new instance of your application. Yes, but you publish a new instance of the reporting API that you use once a week, and a new instance of the session API that you use once a millisecond. So you cannot scale the portion that you want to scale. You have to scale everything, even the function that you don't want. So you need more memory, more CPU, more disks, and of course you make all these cloud providers very happy. Other symptom, you have a huge, big team. Did it happen? You have a huge, big team. You don't have small teams, everybody working on something. You have like a 30 people team, 40 people team, all working together on this thing, and doing this and that, whatever, and there's a lot of mess around, and it's complicated to publish new APIs, and there are congress running on this team with several layers of management inside the team, very complicated. You don't want that either. You have generated HTML page. Well, in certain times and in certain situations, server-side generation is good. But sometimes it's not. So you want to do a dynamic front-end, right? You load all your front-end in advance, so you run a JavaScript application inside the browser, and then the JavaScript application will run and call other services. When you have a monolith, sometimes you are stuck in the previous situation, big HTML pages. Well, we don't use it anymore, but yeah, that's us. Yeah, oh, sorry, I forgot the dog. So, the dog is fine. Wouldn't it be better if, right, you can use an IDE or not? So you can literally open your code in a very easy text editor like, I would say UI, but also Sublime, or even Gedit, whatever you use. I don't know what's on the Mac, whatever you have on the Mac, or on Windows. Notepad? Yeah, that thing. No, you can use that to change your code, right? You can choose your favorite programming language. I have to tell you that I work in London, and a big problem in London is keeping developers with you. Developers want to try new things. I know, I'm one of them. And they will usually run away to another company to try a new language, a new framework, some new shit that we don't know about. They will go there and do it because they like it. And in London, salaries are very high. So you can get a very high salary anyway and work on something else very easily. So you want to give your team the opportunity to work on different languages. And Microservices enables you to do that. In our systems, we have about 50 microservices, and we use JavaScript, C#, Java, what else? Another one I don't remember. Oh, yes, Ruby. Oh, I forgot about Ruby. No, we use a lot of Ruby. And each time we select the language which is better for what we want to do. So if we want to do very quick, if we want to achieve very quickly, get very quickly microservices up, we usually use Node.js, and also enables us to use front-end developers to do the server side. We have a bit of training, but yeah, but we can do that. If we want to squeeze out the very last bit of performance, we can use Java or C++. We have a C++ microservice. If we want to do very complicated object-oriented structure, we use Ruby. So we have complicated models. So it's all about selecting the correct languages, and the microservices enable you to do that. Your integration tests runs in minutes. If you have a microservice, it's small. So your tests are very fast and runs very fast. Your DB migration are small and cozy. So when you have to migrate a database, you have to understand that each microservice has its own database. It doesn't share it with other services. So a migration on a very small database is much easy and takes much less time. And the indexes are small. It's all brilliant. And you can use whatever database you want, really. You can use Mongo or Orient or if MySQL. We use all of that. SQL Server, we use also that, unfortunately. You have small team, pizza size. So because each team will be responsible to one single microservice, or some of them. And you clearly know when something is broken, you go to that team, and that team will fix it. So very, very good. Yeah, we already said that. You work on greenfield project every time. New feature, another microservice, right away. Olé, we do it. So it's much interesting, much more interesting. Again, you can choose cool technologies. And of course, you can fail. So we have microservices that we failed to build. So we built them, and then they were too slow. Well, basically, they were too slow. So we replaced them. So we write a new version of this microservice with another language, maybe another database, and everything goes smoothly. So you can fail much, much more easily. If you fail in the monolith, you are in that big code base that nobody can change. If you fail in a microservice, you rewrite it. It's a couple of weeks, 3 weeks, a month. Oh my God, let's rewrite it. Much, much easier. So what are microservices? Those are basically independent small processes that are talking with some kind of form of language agnostic dialect, like HTTP. For example, our microservices are talking all with HTTP and REST APIs, so very, very easy. They're very small. They incorporate the concept of, if you want, a good object-oriented design, because each microservice is very, very cohesive and not at all coupled with the others, whenever it's possible. And they can be written in any languages. As I said, we use mostly all of them. Oh, we also trying Elixir now. Beat that. You know, who knows Elixir? Yeah, well, you're using that shit. And yeah, of course, they can deploy independently. So you can basically pick up a microservice and deploy it. Yesterday, we did a whole deployment without zero disruptions, with zero disruption to the users, and just because we could deploy them independently. So it was very, very, very cool. Yesterday, the first off-band deployment of everything. Fantastic. And each microservices use its own database. This is very important. So you don't have a big database. You don't have even a shared schema, nothing like that. Each microservice, its own database, their data are there. And as I said, each microservice is owned by a team. So you know who to bug if that happens. So we said that, we said that, we said that, we said that. Yeah, the scaling part is very important. Don't underestimate it. Because especially if you're in a high transaction environment, you want to scale your services independently. So you want to be able to deploy, for example, 10 instances of the session service and 1 instance of the reporting service, and have different policies against them. So, for example, if one of the session service goes down, another one is brought up immediately. If the amount of load increases, then new instances are created immediately. Or if the load decreases, instances are shut down. If reports fail, okay, reports fail. That's it? Yeah, okay, yeah, I'm going to bring it up. Different policies. You don't want to have the same level of emergency on your whole stack. You want to prioritize. You don't have a lot of people. And your critical resources must be assigned to the critical microservices. And critical procedures must be written for the critical microservice, not for everything. Doesn't make any sense. Yeah, I'm very much like the fact. It's growing on me. The fact that microservices are enables for small team. They really enable you to create small teams. And small teams are much more efficient than big teams. Try it if you can, or talk to your boss, and why don't we try split the team in 2 and see what happens? They are much faster. And of course, we do cross-functional teams, so each team has his own QA and ops, but that's not a story. But small teams, big deal. Small problems, you're going to have a lot of microservices. You're around 50 now. And that put a pressure on your ops environment or your cloud or whatever you use there. We have been migrating recently from AWS to Azure, the Microsoft cloud. So, you know, it was tricky. But to be honest with you, The more complicated migration that we had was on the remains of the monolith. The microservices, we migrated very, very, very smoothly. The monolith, we have more problems. Scaling requires thinking and a lot of effort. Again, remember, it's costly to scale everything, put in place, prioritize what you want to scale, okay? And yeah, you have the duplication configuration all over the place, and you need to provide proxying for external apps. Like we have web apps, desktop apps, mobile apps. They all go through a proxy. They don't talk directly to the microservices. They require configuration. And yeah, there are a lot of moving parts, so yeah. But, I mean, go for it. Now, I missed something. Oh, in the meantime, at Workshare, yeah. This is an image of our production system. So those boxes, small colored boxes, are all microservices. And they are color-coded because I've written in different technologies. And the big boxes are machines. We have several of those machines. This is just a snapshot of one layer that we had. But don't be scared of this. It's easy. It's not complicated. Just a lot of stuff. Right. Now, sorry. I'm going too fast. Now, just a small demo. I want to show you some of the microservices that we have just to help you understand what a microservice is. All right? So I will open my browser. Chan, chan, chan. If I have internet, which I don't know. Oh. So, it doesn't look like. Do you have a network cable? Oh, it's there. Ah, no. Sorry, we didn't set up the network cable. Huh? No? No, do we have it? Whoop. No, we don't. No. OK, let me try another trick. Chan, chan, chan. Tethering through the phone. Because I really want to show you exactly what a microservice is and how does it work. And from real example, not bullshitting you, I want to show you real microservices that we have in production so that you know that we are not disconnect. Sorry, just another setup. I do this, I get back this. How we go? I'm using Linux. Beautiful. Some glitches here and there, but yeah, like I don't want to code motion now. I want this one, please. No, I don't want that one. I want this one. Yeah, baby. Now, let's try again. Yes. So this, for example, is a microservice. Now I'm showing you the QA environment. All our microservices have documentation on board, so you can access an endpoint, usually access / and you see a documentation. This documentation is written by Swagger, which is a very useful system. And basically, this is a very important microservice. It gives you the time. This is the official source of time for all our microservices. And believe me, in our job, it's very important to have an official source, right? And this is also replicated. So I can go here and open this one and fantastically ask, well, what is the time? And the time is this one, right? So this is the kind of API we're talking about. It's a simple GET against an endpoint. And then we have a much more complicated API where I can ask the time for a specific clock. So clock is my mommy clock. I try it out, and I get the time of my mommy clock. So that looks funny. But for example, we do use this microservice in our tests, in our integration tests. We do have integration tests which are across all the web system and APIs that runs in a couple of hours. But are really end-to-end tests. So we open the browser, we do stuff, and then we check on the other side what's happening. So this is very important for some services that need to elapse time. For example, reports, again. We write reports every 2 weeks, right? We cannot launch a test and wait 2 weeks. So we go here, our automation, go here, changes the time, and then execute the test and verify that the report after 2 weeks is executed. So basically, through this API, I can fake the time, and I can put a fake time inside. Now, another microservice, for example, another simple one is location, which is not up at the moment. Oh, no. OK, I didn't test this one. So let's check another one, a complex one. So actually, I can run location locally. Can I? Yeah, I can. Of course I can. Well, I'll do it later. So another complex microservices is this one, for example, groups. Groups is a, oh, come on. I don't have the entries. I didn't check the entries. Ah, shit. Wait a second. So you don't see any password, right? No, you will not. I'm open the VPN to connect directly to the company. If it works on the phone, maybe. Yeah, here we go. So here we go. I'm going to the QA Jenkins, the one that we use to manage our smoke testing systems. Services, here we go, services list. And there we go, version report. So this is, for example, all the services that we have on a different environment, live. This is where we are now. So I wanted to show you location. Let's pick up one, for example, this one, which looks good. Here we go. So this is location. Yeah, each microservice also exposes information about itself. So this is the version of the microservice. You can see the git commit ID, very useful, the tag of the Jenkins system. And you can also ask the microservice to do other things, like health check. You can, how are you, guy? And you ask the microservices to perform an health check. This is how we do basically polling monitoring. We have active monitoring, but we also poll monitoring these endpoints. Every microservice is able to tell you, I'm OK or not. But let's go back to the fantastic API. This one is simple, because basically, given a simple IP, it will tell you, nothing. Because because I have to go straight to the system. Sorry. I cannot show you this one. I'm very sorry. But what does this microservice? Because we have proxy in the middle, and I didn't forget about that, and through the VPN I can access to the proxy. However, what does microservice do is basically giving an IP, it will provide you a location, a physical location, like it's in Europe, it's in Netherlands, it's this city. And this is useful when, for example, you want to know when the last login was from, right? And this is a very simple microservice that does that. Now, enough of this. Let's go back, and I'm going to show you some Node.js thing. So we started using Node.js just 6 months ago, and basically it comes to me through a revelation during Sunday. I decided to try Node.js, and in 2 hours, I built the demo that I'm going to show you today. And I didn't know anything about Node.js, zero. I did know zero about Node.js. In 2 hours, I built this demo. So the first is very simple, of course, but then you will see it gets complicated. So as long as you know JavaScript, bits of it, you can use Node.js straight away to produce server-side systems that are very, very fast. Now, here we go. Now, this is the first part of the demo. Is very simple. I'm going to show you the hello microservice, the one that everybody shows you. So basically, you run it, right? And it will start on a port in this 3001, a random one. And then I can call him. I do a curl. So curl is a command that allows you to do an HTTP request to an endpoint. I do a curl, and I see the results, and say, hello, stranger. Beautiful. So this, as long as this looks stupid, in reality, it's very complicated. To build the same thing in other languages, it will take you a long time of setup and preparing and coding and a lot of stuff. In Node.js is, is this one. This is the Node.js part. So it's basically a couple of lines, and it's done. Node.js creates a web server for you, that responds to a get, okay, and send back text. It's one line. It's just that. So it's just that dead simple. And it's incredible how simple it can be. And when you come to microservice, of course, you have lots of them. So let's consider a more complex example, all right? So let's consider a situation when you have several of them, right? So imagine that we have, oops, no, this doesn't work. No, oh. So imagine that we have alias, source, several of them, all right? Now, we have the same thing. So we have an hello microservice, but we have other two microservices. This one tells you the time, and it starts on port 3002. This one tells you a random number, and starts on port, node, I don't know, let me see. I have no idea. On 3003, cool. And this is the same as before, right? Now, if I call as I did before, you will see that the response is slightly different, no? It says, today is whatever, the time, your lucky number is 21. And I can do it again. I will continue to ask to the two other microservices. So I hit the main microservice, and I will talk to the two other ones, collect the information, prepare a response, and send it back to me. How difficult it is? It's very easy. So I can show you. So this is a time microservice that gives you the time. Super easy. Single request, no? It gives you creates a date, translate to ISO string, and you see how you create a JSON content, response.json, blah. Easy. And this is the random number. Same thing, creates the mat.random function, right? Then creates a JSON, done. And the hello is slightly more complicated, but not as complicated as you think. So you see, this is the hello. The hello basically will respond to a get. And what will it do? Here I'm using a package which is called async, which is very easy to use. Async has a function called parallel, which does things in parallel. So, oh my God. So what I'm doing, I'm calling in parallel the time microservice and the random microservice. I'm collecting the answer in those two variables, time and rand, and then have a callback function at the end that is called by Node. So Node will call the other microservice to the parallel system, and then it will call me back when I have the results. And I will end up composing these results here, which is slightly more complicated. But it's not that complicated. Again, bit of Google, find the async function, maybe a bit of Stack Overflow. Then you read the documentation, read the manual, easy to go, read your code, done. Do you understand it? Are you understanding this one? See? Yes? Yeah? What's the Netherlands thing for that? Yeah. Cool. Sorry, I don't know. I mean, I've been here 6 months, but I was studying English, so sorry. I can say Dag. That's it. Entschuldigung. No, that's German. Yeah. So it's very, 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 very easy. Let's go back to a slide for a moment. We come back to this code later. What I want to show you now, the important thing for me, and you get the gist of it, you get to understand how easy are microservices, how easy Node.js, and how easy is going and do it yourself. You should definitely try. My intention here is to force you to try because it's easy. This code is on my GitHub anyway. So the common antipattern we can see later because we are running out of time. How much time do I have? 10. So if I can go back to one thing, I want to show you one thing first. The presentation is much longer. You have the slides. But yesterday somebody told me, oh, but Node.js is quite slow. And I said, what? This is our production environment. We have one misbehaving Java microservice that usually clogs up our MongoDB machine. We have a big MongoDB cluster, and a single damn instance of the Java microservice is able to kill it. Basically, what happens? Happens this. Specifically, this. Load average 79.47. So on a normal computer with one CPU, that number should be 1. In this situation, it's 79.47. Does this bother Node.js? No. It doesn't give a shit. It continues to work. You have the same Node.js microservices running there and continue to provide. Even 80%, 80, load average of 80, Node.js will continue to work. It's incredible. Nobody was believing it. My head of DevOps come to me, what's happening? What? We have an 80 load average on, yeah, we know, it's POP, it's a Java microservice, we know that. Yeah, but Node.js continue to deliver. Well, that's good. Yes, let's rewrite everything in Node.js. Yeah, you're pushing it a bit too much, but we will get there. So I was really keen to show you this because it's very, very important. Just to tell you my story, how did we start using Node.js? I decided it was a good idea, and I started training my developers with myself, and now we're building Node.js. I have the advantage of being head of engineering, so I can do pretty much whatever I want. So yeah, that's a big advantage. But if you can convince people very easily. When I tried to convince the Ruby guys to migrate to Java, no way, they never did that. They don't do that, they don't want to do that. But this stuff, so let's go back to the code for a second, because we don't have a lot of time. So I want to show you a more complicated system, which is part of the 2 hours that I spent. So, which is the third version of this. So in the third version, we have a new microservice, which is a sort of registry, basically. Basically, it will tell the other microservice where to find the services. Because this is a big problem. When you have a lot of them, a lot of microservices, and a lot of them are replicated, the problem is, how do I find who I should talk to obtain this service? And this is a very simple example, very stupid, but just to show you the power of Node.js, all right? So I'm going to start here, my fantastic registry microservice, which is basically a registry. It will register other microservice and check that other microservices are online and working. Then I will start the other version of the other microservices here. No? And when the microservices are starting, as you can see, they register on the registry. So I start the random there, I start the time there, and both of them registered on the registry microservice. Now, if I go for hello, and I call hello, no, hello will call the registry and ask him which services he should use, and then he will call them and obtain a number. The good thing about that is that I can run another instance of the random service here, for example. All right. So, sorry, another port, 7777. OK. So I'm running another instances of the random microservice. It will register here on the registry. You see, the registry now show rand on 2 ports, 3300, 7777. And times is on 300, 200. So what I can do now, I can kill this one. I killed it. Sorry. It's bad boy. So as you can see, the registry detected that the service wasn't working anymore, right? And now the registry changed themselves, healed themselves. And now if I call now, sorry, the other guy, it will work seamlessly. But he will use a different instance to do his job. So you may think this code is complicated. It's not. It's easy. Easy peasy Japanesey, you say in England, apparently. So I can show you. Oh, too many S. So each microservice has now a very stupid function. This is a very stupid example. Don't do this in production. But it gives you the idea. It gives you the gist of it. You can do it. So every microservice has this stupid function. So set interval. That means that every 5,000 milliseconds, this service will call the registry and says, I'm here, I'm alive, right? It will also expose another endpoint called ping, which magically will respond pong. And why this? Because the registry will receive the registration of this one, and then the registry will call ping, are you alive? Are you alive? Are you alive? When it senses that the other one is dead, it will remove it from his list. So two functions added here. The same functions. The registry is also not that complicated. It's big, but not that complicated. So yeah, maybe it looks complicated, but it's not. We're still within a almost a page. So this registry, it has an endpoint to receive a registration. It has an endpoint where you ask, where can I call this service? We return you a port. And as this function set interval again, that it checks every 10,000 milliseconds, so every 10 seconds, it will check every service and call ping. If it doesn't receive a pong, it will disregard, will remove this service from the registry. And the hello is much similar. So in the main function, nothing changes. But you can see those two variables, port time and port run, that I made global. Who cares? It's a microservice. I can do it. JavaScript guys don't like it, but it's a microservice. I can do it. And basically, it has this set interval function that every 2,500 milliseconds, it calls the registry and it collects the port where to call random and time. So for that reason, if I kill one of the microservices, the system will continue to work. -1. OK. So this may look complex to you. I think it's not complex. And I swear that I did it in 2 hours, and I'm not a genius. I did an interview at Google. They didn't accept me. So I'm not a Google man. Did it at Amazon, didn't accept. Not an Amazon man. I still have to try Facebook, but I think they won't like me. So I'm not a genius, all right? Normal guy, lots of experience, but also an old fart if you want. So if I did that, you, young and bright, you can do much, much better. You are here at the conference. You are the good ones. The bad ones are at the office. You here are the good ones. You are the ones that want to learn new things. This is amazing. Keep going. Do this. Do all the other stuff. I mean, there's a lot of things going on in this conference. Follow and do. You're going to change things. I'm too old for that. You're going to do it. Come on. I made you study for that. No? Pay your fees, whatever. So, as I have 1 minute, I don't think I have time for all these fancy slides, but they're very good. So there's a lot of antipatterns that you should know when you do microservices. And those are all in my slides. You will download them. And, this is good. Right? So there's a lot of things that you should learn. But it's not that complicated. It's all very just... poor guy. It's just very simple stuff. And you can really learn it in a moment. OK? Now, that's good. Yay! This is where you can find me. You can find me on Twitter, on Gmail. Have a blog, which I sometimes update, sometimes not. And yeah, I think that's it. So if anybody has a question, I was waiting for this. Anybody has a question? No, because you know this thing is a microphone, and I'm supposed to throw it at you, so you can answer the question. But I will be gently. Oh, God. All right. 1, 2, 3. Almost. Sorry. I killed somebody yet? No. Yeah, I'm not a sportsman.
Okay.
I play rugby.
I did. Oh, yeah? Huh? I have to. Oh, nice. Oh, it works. Well, somebody was too shy to make the question, so I'm gonna take a comment I heard. Something like your ping implementation was actually quite simple.
Yeah.
I guess you in production should have something kind of more complex, because your microservices were trivials. You mentioned that each microservice has a database, for example.
Yeah.
So do you have like an LT check? I mean, does ping tell you, well, the microservice is on, but the database, it's not working, or I don't know?
All our microservices have health checks embedded in it. If we're using, for example, for Java, Drop Wizard, which is a framework, and actually using only some part of it, but it gives you this ability to create endpoints that can health check your system. So if you saw the previous one, the one that I had before, like was this one, for example, this is a health check of a real microservice, which is currently in production, prod.blah. And this is basically checking 3 things: the connection to Mixpanel, the connection to the database, and it's also verified that the Mixpanel is really working, because sometimes Mixpanel says, yeah, I'm working. No, you're not. Joking. So it's also tracking really that Mixpanel is there. And we have much more complicated microservices that do a lot of checks. So every microservice has this thing, but they do also have the ping. We're not using the ping for the purpose of We're not using the ping for the purpose that I showed you, because that's a very easy implementation. In reality, there are frameworks that allows you to do these things. For example, console is one of them. Allows you to list and registry and manage a cloud of microservices. These things are already done. We've wrote ourselves one. There are others like, I think I have a slide about that. I don't know where. I think I have it in the Antipatterns. Wait a second. Yeah. Where is it? Not the crapper. Yeah. So when you want to know where to call, where is my microservice, there are a lot of solutions available in the market. I suggest you use those ones. So Eureka, Zookeeper, Console. We built our own system, early days, but there's already a lot of things that are doing that for you, right? In regards of health checking and monitoring, we have continuous monitoring on the system, on the machine. We are health checking through also continuous, and we have smoke tests running continuously. So having continuous check of what's going on, it's a must. I mean, if you don't have it, if you don't have good monitoring, at least 3 layers of monitoring, we have 4, you are in trouble, even with normal monoliths. But microservices, more. Cool? All right. Any other question? No? No more question, I'm sorry. You can catch me when I'm around. So, and have a nice lunch, and enjoy the rest of the conference. And good congratulations for you to being here.